wonderful students. This is our mid-unit test. Today is Thursday, a catch-up day, but Friday when I have class. And for those of you who can't make it, this video is here to help you with these big ideas. The mean. All you're going to do is you're going to add those numbers up and then divide by how many numbers, okay? I'm not going to solve these because it's just more of a thinking idea and I want to make sure you guys got it. The mean of the data set just takes some time, right? 12 plus 14 plus 16 plus 14 plus 13 plus 18 plus 20 plus 16 plus 14 plus 23. There's no fancy way for me to solve it any faster. There's no fancy way unless you're using computer systems, which I can show you. Enter. I got 160, but you should probably check it. Now, how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. That doesn't let me see. All right. Well, eek. I don't know. You figured out. I got 16, but I make mistakes too, so check it. And I'm not going to check it right now, so you have to do it. Okay? Add them together. Count how many you added. Divide by how many you added, and then you get the answer. Does that make sense? If it doesn't, please ask me, because the mean is something that the average. Finding the average of things is important. Boop. The table shows the hours worked per week by employees at a department store. Is that the same for all of you guys? Okay. What is the average to the nearest tenth? See, that's nice. What is the average number of hours worked? Tenth by all employees? By all employees. So you must have different tables, okay? So this should be a frequency table. Let me scroll down. You're going to have different numbers, different variations. You have all 3 attempts on this. This is what is the average number of hours worked rounded to the nearest tenth of an hour by all employees? Okay, down here is the number of employees who worked this this week, okay? So what we're going to do is use the frequency table thing, or the frequency. This is a frequency table, but we're going to use that method where I do, hey, 11 employees worked 10 hours a week. So that's 11 times 10. So I'm going to try it. Definitely check it. You might have, and you're going to have different numbers. You may not have this one. So 11 times 10 plus 16 times 15 plus 20 times 23 plus 30 times 18 plus 35. Nope. Oops. I see I typed 25 on accident. So you got it. Yeah. Please check your work. Don't just pick my answer, because I make mistakes too, and I would go slower and check it. All right. So, wow. So all of the hours worked, like by everybody there, was 2,285 hours. So that's how many hours the company had to pay them. The department store had to pay out that many hourly wages, 2,285 hours. So whatever your hourly wage is, I'm sure there's different, because different people, different amounts of time, different jobs. But anyway, that's how much the company has to pay each week to their employees. So remember that when you think about prices and companies and all that kind of stuff, it matters. Anyway, so 2,000, that's what I found. You check the math. But now what do we divide that by? What do I, 12, 23, 50? Do I add them all together? No. You need to divide that by the number of employees added together. Because the math we did is like we added together 11 tens. It's like we added 16 15s. It's like we added 20 23s. It's like we added 18 30s and so forth, right? Because we are adding the hours worked per employee. So now to figure out what to divide by, you're going to add up the number of employees, because we were adding each of their weekly hours. That was the data, not the other way around. Like the best way to understand that is think about if you had to list out these data points, what numbers would you be listing? Would you be listing 10 11s, 15 16s, 20 23s, or would you be listing 11 10s, 10 10 10 10 10 10 10, right? On my table for all my employees. So think about that. That might help. So 2285 divided by 93. Remember, check your math. 24.56989247. That's about what I get. That's the average hours worked by all the employees that week. That number makes sense to me. If you get a different number, like a really small one, like 3 or 4, that doesn't make sense. Nobody even worked that much. If you get bigger than 40, that doesn't make sense. Nobody worked over 40, so how could the average amount of time that we worked together be over 40 hours? It's not even in our data set. So always think about, what do the numbers mean? Does my answer make sense? If yes, go for it. Go for it. If you get it wrong, no big deal. No big deal. Try to figure out what happened, simple adding error, and then move on. Boop. What is the range? In order to find the range of the data set, you need to put it in numerical order. So find the smallest value. This might take some time. Okay, I think this is the smallest. Then find the largest value. Whoop, whoop, whoop. I think this is the largest value. But all you do is take the maximum, subtract it from the minimum, and that's your range, right? If somebody asks you, what's the age range of my class? Well, that depends. In my Algebra 2 class, I've got some 8th graders. They're 13. I've also got some seniors who are trying to pass to graduate. One of them's 20, 19, 20. So my range is from 13 to 20, let's say. So it's 7. I have a 7-year age range. Same idea here. Decimals don't matter. Fractions don't matter. The range will always be, take the highest value, subtract the smallest value from it. That's your range. BoxPlot shows the number of hours 220 people spent on a computer on a weekend. How many people spent more than 13 hours at a computer? Okay, the big idea behind BoxPlots is it breaks your data into fourths. It breaks your data into fourths. It will tell you the minimum value. It'll tell you the maximum value. It'll tell you the median, the middle, not the mean. It'll tell you the lower quartile and the upper quartile. So we call it the 5-number summary. I'm sure you've seen it. Hopefully you've seen it. It's in the lesson. You should have seen it. Min, Q1, median or Q2, they're both the same. Q3 and max. But the idea behind a visual box plot is between the minimum and Q1, that whisker, that's a fourth of our data. Between Q1 and the median, that little first chunk of the box with the line in it, that's a fourth of our data. That from the median to the quartile 3, the end of our box, that's a fourth of our data. And then from Q3 to our upper whisker, the max, that's a fourth of our data. So it's just like a visual representation, and it chunks our data so we can kind of see where the majority of it is. So let's go scroll down. Gotta go slow. So the way we read it is, all right, 3 is our minimum. 6 is our Q1. Ooh, look, our median, our middle, is all the way over there at 13. Our Q3 is 14 and our max is 16. So what is the question? About how many people spent more than 13 hours at a computer? Well, here's 13 at our median. Our median splits our data in half. Because see, there's 2 quartiles up here. There's 2 quartiles down there because each section is 1/4. No matter what it looks like visually, that's just a visual representation. So you can kind of picture, oh, wow, look, something's here. It's really spread out here. What's going on here? How is this the middle? Anyway. So hopefully that helps. No matter which question you have, more than 14 hours. So now you got to look, where's 14? What's a fourth, a half, 3/4? That's usually what they're going to ask you, okay? more than 6 hours. Okay, let me know if you have questions about that, but that's what a box plot is doing. That's why we have quartiles, and it's why they're useful. I'm not a fan of them, but that's okay. What is the 5-number summary of the data set? There you go. We talked about that. So you're going to find is it in order? Oh, it's not quite. It's not in order. Don't let them trick you. You have to put it in numerical order. So looks like 12 is the min. There you go. That's one of them. That's one of the 5 numbers. What's the max? 19, 18, 19. 19 is the max. So we got 2 numbers. 12, min equals 12, max equals 19. Put it in numerical order. You can't find the middle. Let me see, 1, 2, 3, 4, 5, 6, 7, 8. So the middle is going to be with 4 numbers and 4 numbers, but it will not be this because it could be, but you have to put it in numerical order first. You have to. Okay? So you have an even data set. That means you're going to have 2 numbers in the middle. Okay? So you'll have some number X, some number Y. You need to add them together, whatever you get. Probably what, 15 and 16? Yeah, probably. I don't know, put them in order, check. So you would add those together and then divide by 2, right? So if you had 3 and 4 in the middle, you would add those together and divide by 2, you'd get 3.5. That is your median or your Q3. The median would be 3.5. So you have to check it for this one. Now, you do that same thing again for Q1 and Q2. If I have data, and I'm just going to do okay. If this is my data, I've put it in numerical order. I find my middle. There it is. See, 1, 1, 2, 4, 5, 5, 6, 7. These are my middle 2 numbers, so I do 4 plus 5 is 9. So I divide it by 2, so I should get 4.5. And that makes sense, right? Okay. So far for my min, I would have 1. For my max, I would have 7 for my 5 number. For my median, I would have 4.5. Now I need to find my Q1 and my Q3. Okay, I'm going to do the same thing, only now I have 1, 2, 4. So I look at just these numbers for my Q1, my lower quartile. It's right here. 1 plus 2 is 3, divided by 2 is 1.5. So my Q1 for that one is 1.5. Up here I have 5, 5, 6. So 5 and 6 are in the 5, 5, 6, 7. So this is the middle. 5 plus 6 is 11. 11 divided by 2 is 5.5. So that's my 5-number summary with my numbers. You need to do it with your numbers. Put them in order. This one has 8. So that means you're going to have 2 middle numbers. That will be your median. Add them, divide. Then you do the same thing, repeat the same process for the lower quartile, Q1, and the upper quartile, Q3. Let me see if they give you an odd. 1, 2, 3, 4, 5, 6, 7, 8. Nope. They're all going to be 8, I think. 1, 2, 3, 4, 5, 6, 7, 8. Okay. You have an even data set, so you have to do a little bit different. If you had an odd data set, just real quick. 1, 2, 3, 4, 5. This is terrible. This is horrible. I need more numbers. 6, 7, 8, and 0. 1, 2, 3, 4. This is our median. That would be our median. We don't have to do anything. It's smack in the middle. See, 0, 1, 2, 3 is on the left. 5, 6, 7, 8 is on the right. It splits it in half. That's our median. Our Q3 would be right here. It'd be 1.5 because we'd add those. That was our Q1, excuse me. Our Q3 would be up here. It's 13, 6.5. Okay. And then our min would be 0 and our max would be 8. If you have an odd, even if this was an odd, say there was a number down here, you would just circle it. You don't have to do any math. That is the middle. That number is the middle. If you have even groupings, then you have to add them and divide. If there's an odd number and you can get an exact middle, that's it. You're done. Okay, just want to make sure I talked about that. Oh, outliers. Okay, so now you have lots of steps. Let's solve this one. We're going to actually solve this one. So if this is your problem, great. Let me see if there's any higher ones. Okay, we'll do the 40s. Leave the 70s for you guys. Nah, we'll do the 70s because if somebody has the 70s, they got to pay attention to what the numbers are. Okay, here we go. Let's do it. I only have a couple minutes. We got to finish. Here we go. Ready? We have to put in order 61. Oh, crap. 58. Okay, so we have 66, 66. 67, 68. There is no fast way, friends. You just gotta get it. 70, 71, 72. So 70, 71, 72. 70, 71, 72. So 78 and 80. 78 and 80. Question 6 going to take some time, okay? Our interquartile range is what we need. 1, 2, 3, 4, 5, 6. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, that's nice. 1, 2, 3, 4. 1, 2, 3, 4, 5. This is our median. 1, 2, 3, 4, 5. Okay, this is our Q1. See, it's smack in the middle, no math. And our Q3. Excellent. Our interquartile range is going to be the Q3 minus Q1. That's it. So 7, that looks like 6. So our IQR is 6. Now we need to do 1.5 times 6. My math, no, 9. Okay. Plus and minus, plus 9 and minus 9 will give us outliers from our min and our max. No, from Q1 and Q3. Got it. Oh gosh, my brain. Sorry about that. So we have 66 minus 9, 57. It's not an outlier. We have 72 plus 9, 80, 81. It's not, there should be no outliers. No outliers. There should be no outliers, and that's because, so sorry, we have a bound for outliers. Now we have a mathematical equation. We're not just looking at the data and being like, that looks far enough away. Well, let's throw it out. No, you need to think about it. And we have a math, we've said that if we take the middle 50%, right, from Q1 to Q3, this is our middle 50% of our data. Half of our data is between those two numbers. So it's, okay. If we take this and we find the range, so in our case it was 6, well, a reasonable outlier would be if it was 1.5 times, so 1.5 times the IQR, the interquartile range, right? Because most of our middle half of our data is between these two numbers. So if it's 1.5 times away from it, we're going to consider that an outlier. We're going to say that's too far away from our data that I don't want to throw it out. So our lower bound would be the Q1 minus this. Our upper bound would be the Q2 plus this. That was the math I was kind of rambling about that I didn't explicitly write on the board. And I confused myself. I did the min and the max, and that doesn't make sense because obviously if you have your minimum number and you subtract from that, none of your data is going to be below your minimum number. So you'd never have any outliers. So that made no sense. And if you add to your maximum value, none of your data is going to be bigger than your max value. Otherwise, it wouldn't have been your maximum value. Now, would it? So lower bound, upper bound for what we consider outliers. And in this case, because the IQR was 6, because like I think the interquartile was, or the Q1 was 63 or something, and the other one was 68. I can't remember. That's 5. Doesn't matter. When I did this equation, I discovered, hey, this one didn't have any outliers. I'm going to pause it and see if they all don't. Hold on. Let me zoom out. Okay. Check your math. Check your numbers. They're pretty close. But some of them do indeed have an outlier, and you can't really tell just by looking at it. Okay? Okay. All right. Question 7. Wait, did I recording? Yep. Last question. I got to go. Which box plot represents the data set? Okay, let's make a box plot. Let's make a box plot. Some things you can already look for is min and max, right? But let's put it in order. This one has a minimum of 13. 13, 14, 15, 16, 17, 18, 17, 18, 19, 26. Okay, so I'm just going to kind of do it. 13. How many points are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's nice. 13, 14, 15, 16, 17, 17, 18, 18. I can't do it any faster. I thought I could, but I can't. I'll mess up. I don't want to mess you guys up. You just got to do this work. It wasn't too bad. And on paper, it's even faster. It doesn't hurt. 13, 14, 15, 16, 17, 17, 18, 18, 19, 20, and 26. Let's find the middle. 3, 4, 5. This is going to be the middle. 1, 2, 3, 4, 5. Okay, that number splits my data in half. That's my median. So on my box plot, I'm looking for 17. So now let's go find my Q1 and my Q3 and my min and my max. That should be 26. That should be easy enough. 13. That should be your lowest number. Easy enough. If you're struggling with that, then you need to reach out so I can come up with strategies for number sense and ordinal numbers, right? Anyway, you shouldn't. 17, and then here, this are the two parts. Why is it 15? Why is it 19? What's going on here? Okay. We have our min, we have our Q1, we have our median, we have our Q3, we have our max. Now the box plot will not look like this because see, mine data is evenly spaced, but a box plot will be over a number line. So you need to look at where these different parts line up, if they line up accurately or if they're labeled accurately. It will not be even like this, especially this 19 to 26. There's 7 over here, whereas over here there's just 2, right? There'd just be 2 tick marks for our min and our box plot, but over here there would be 7. 1, 2, 3, 4, 5, 6, 7. Thank you for watching. Thank you for thinking. Reach out to me if you ever need anything, an email, phone, text. Join those live sessions, join my help labs. Otherwise, keep working hard, get this done, have some fun, and remember, this is all around you. Maybe not box plots, that's true. I haven't really used box plots. I have used almost everything else. Box plots are just fun, box and whisker plots. So have fun, and thank you for thinking, because at the end of the day, that's what is really, really important.